Hey grade 10s, today we are going to do chapter 7.5, solving linear systems using the elimination method. This is the last method that you are going to learn to solve systems of linear equations. In the elimination method, you either add or subtract the equations to eliminate a variable from one equation. So how do you know when to add and how do you know when to subtract? Well, if you remember from integers, when I add opposites, 3 and -3 are opposite, they're on opposite side of the equal of 0. When I add opposites, that creates 0. If I do that with a 3x and a -3x, I'm also left with 0, nothing. I've eliminated the variable of x. So if I add opposites to equal 0. So when do I subtract? Well, I subtract, if you think about it, if I have the same number, I have 3 and I subtract 3 from it, that also creates 0. Or if I have 3x and I subtract 3x, I'm left with 0. So subtract equal values. So 3 equals 3, so I subtract. 3x equals 3x, so I subtract. And when I subtract equal values, I get 0. Let's take a look at this first example. So solve the system of linear equations by elimination. The first equation is 2x plus 1y equals -7, and the second equation is x plus y equals -4. Both the equations share variables x and y, and both the equations, the coefficient for their y value is 1. So I have 1y here, and I have 1y here. Both of them are positive 1y. So if I come up here, they're not opposites, so I'm not going to add. They're equal values, so I'm going to subtract. So if I take 2x plus 1y, subtract 7, equals -7, and I subtract x plus y equals -4. So I get 2x, take away 1x, gives me x, or 1x. Y, subtract y, is 0, so I've eliminated the variable of y, it's gone. Oh, and this is supposed to be a 4. Shoot. And then I have -7, subtract -4, that equals -3. So right away, I've eliminated the y from both equations by subtracting, because the coefficient in both cases was equal. They were equal to each other. They were both positive 1. And that gave me x equals -3. Then I'm going to take x equals -3 and I'm going to substitute it into the first equation. It doesn't matter which equation I substitute into, I am going to get the same result. So I have 2 times -3 plus y equals -7. This equals -6. So I have -6 plus y equals -7. I'm going to add 1 to both sides. So then I get, add 6 to both sides. then I'm going to get y equals -1. So my solution is -3, -1. I want to verify that really quick, just to make sure that I've done this correctly. So in the first equation, I have 2 times -3 plus -1 equals -7. 2 times -3 is -6. And -6 plus -1 is -7. So my solution worked for the first equation. I'm going to try it on the with the second equation now. So -3 plus -1 equals -4. -3 plus -1 is -4, and -4 does equal -4. So this solution of -3, -1 solves both equations correctly. Tells me that my solution of -3, -1 is correct. Let's take a look at the next example. Example 2. So here's my first equation. Here's my second equation. My first equation is 2x plus 5y equals 13. My second equation is 1x plus 6y equals 10. So in this case, neither equation has a variable that is opposite or equal to each other. So what I'm actually going to do is I'm going to manipulate these two equations so that I can get a situation where the coefficients are equal or opposite. And I notice that if I multiply this equation by 2, it's going to become 2x plus 12y equals 20. 2 times 1x is 2x, 2 times 6y is 12y, 2 times 10 is 20. And now, with my revamped second equation, I have 2x, and the first equation has 2x. So again, I have coefficients in both equations that are equal to each other. And in that case, I'm going to subtract. So I'm going to have 2x plus 5y equals 13. And I'm going to subtract 2x plus 12y equals 20. 2x, take away 2x, is 0x. So this is, the x is eliminated, it's gone. 5y, take away 12y, is -7y. And 13, subtract 20, is -7. I divide everything by -7, and I get y equals 1. Okay, so I have y equals 1. I'm going to take y equals 1 and I'm going to substitute it back into the first equation. So then I'm going to have 2x plus 5 times 1 equals 13. 2x plus 5 is 13. I'm going to subtract 5 from both sides, and I get 2x equals 8. And then I divide everything by 2 to get x equals 4. So the solution to this equation is, or this system is 4, 1. I want to quickly verify that my solution is correct. So 2 times 4 plus 5 times 1 equals 13. 2 times 4 is 8. 5 times 1 is 5. 13 equals 13. So my solution works for the first equation. Both the left-hand side and right-hand side are equal to each other. Now in the second equation, I have 4 plus 6 times 1 equals 10, which is 4 plus 6 equals 10, and 10 equals 10. So again, both left-hand side and right-hand side are equal. So my solution to this system is 4, 1. Next example. Solve this system of linear equations by elimination. I have my first equation is 5x plus 4y equals 6. And my second equation is negative 2x subtract 3y equals negative 1. So in this case, I don't see an easy way to just multiply one equation in order to get the coefficients to be equal. But I do notice that I can change, if I change this first coefficient to 10 and change this coefficient to negative 10, that the coefficients will be opposite, and then I can add. I could also recognize that I could change this to 12 and this to negative 12 and do the same thing. Doesn't matter which one I decide to eliminate. It's kind of a preference. I always decide to eliminate my x's first for some strange reason if I can. It's up to you what you're going to do. So I'm going to times the first equation by 2, and I'm going to times the second equation by 5 in order to get the coefficients as opposites. So the first equation becomes 10x plus 8y equals 12, and the second equation becomes negative 10x subtract 15y equals negative 5. Now my my coefficients for my x's are opposites, so I'm going to add these two equations. 10x plus negative 10x is 0x, so the x has been eliminated from these equations. 8y plus negative 15y is negative 7y. And 12 plus negative 5 is 7. Divide everything by negative 7, and I get y equals negative 1. Then I put my answer for y into my equation, so I have 5x plus 4 times negative 1 equals 6. And I get 5x subtract 4 equals 6. I'm going to add 4 to both sides to get rid of the subtracting 4. I get 5x equals 10. And I divide everything by 5 to get x equals 2. So my solution is 2, negative 1. I want to verify that really quick, just to make sure that I haven't made a silly mistake somewhere. I go 5 times 2 plus 4 times negative 1 equals 6. 5 times 2 is 10. 4 times negative 1 is negative 4. 10 plus negative 4 is 6. So 6 equals 6. So left-hand side equals right-hand side. This solution works for that, my first equation. And in my second equation, I have negative 2 times 2 plus, subtract 3 times negative 1 is negative 1. 2 times 2, negative 2 times 2 is negative 4. Negative 3 times negative 1 is positive 3. So negative 4 plus 3 is negative 1. And negative 1 equals negative 1. So this solution of 2, negative 1 also works for the second equation. So that is my solution for that system of linear equations. So again, really quick, you're trying to either add opposites. Adding opposites creates 0. Or you are subtracting values that are the same, also to create 0. When you do that, you eliminate a variable, and then you take your first solution and you substitute it into one of the equations. Okay? You are allowed to manipulate, just like we did right here, where you're allowed to manipulate the equations in order to make the variables or the coefficients be either equal or opposite. Okay, so in this case we multiplied by 2, the first equation by 2, and this equation by 5, because we noticed that the first coefficients could both be 10 or negative 10. Okay. Let your teacher know if you have any questions about 7.5. Talk to you soon. Bye.